next talk is going to come from Sarah Seitz, and this one is going to be about data synthesis for drilling and sampling in analog studies. So Sarah, it's all you.
All right, thank you very much. I'm going to share my screen. Is everyone able to see that?
Yep, looks great.
Okay.
And you just went out of presentation mode. I'm not sure which not to. There we are.
Thank you very much. So my name is Sarah Seitz. I work in the Deployable Automated Technologies group at NASA Ames Research Center with Dr. Brian Glass. And over the last number of years, we've been working on a number of analog site studies in a variety of locations, including the Rio Tinto mine in Spain, Houghton Crater in the high Arctic in Canada, and most recently, the Atacama Rover Astrobiology Drilling Studies project in the Atacama Desert in Chile. We have been working on synthesis of our data, noting that particularly on this project, we had a group of as many as 40 co-investigators and collaborators at a time on site with us, multiple instruments and samples and data returning to multiple organizations and locations at the end of each season. And in addition to that, our 4 successive field seasons traveling not only to the Atacama Desert, but to multiple locations within the Atacama and collecting samples there. So our challenge has been to synthesize the data that we've generated from, in particular, the sites where we conducted our rover drilling studies with our instruments on board the rover, and where we conducted our remote operations during our final year. We have multiple locations even within our local site at Estación Yungay in the Atacama Desert. And the challenge for us is not only that we're working across these multiple sites, these multiple instruments, but also over time. And with the instruments being in development as we move through this process, we have some samples that are being collected and delivered to instruments on board the rover. Other samples, due to operations timing or readiness, are being collected manually. And in addition to that, in the field, we're logging both manual notes out in the elements and the telemetry on board with the drill on the rover. So we found ourselves with a challenge both tracing that data and making that sample analysis traceable back to the drill data itself. The challenge that we've been working with over recent months is how to model this workflow and bring it back and anchor it to the data model that we want to have, so that we can visualize this data and ultimately make a model that correlates it spatially and in time. Currently, what we're focused on is our depth logs, which we generate often through manual notes that are taken in the field while out on traverses. The sample curation that we have as we gather our samples, both in the instruments and manually using, depending on the individual study and the day of our operations, may have a different motivation in terms of it being a tracer study or a study using a given cleaning protocol, and correlating those again to our drill telemetry, which is sampled, of course, at a very different rate multiple times per second, with its own onboard reporting and analysis. One of the key challenges that we found with that is, again, because we're working year to year through these projects, there's a range of formats that end up being used, and we also have personnel in different roles rotating in and out as we work in the field. So we've been working most recently to evaluate, one, our software options, but also to begin developing a data schema that would allow us to merge these data streams together, taking into account that we have multiple file formats, that we have multiple collaborators, including people who are rotating in and out of operator roles within the field when we're out there exposed to the elements, and considering that that data is being generated and stored at different times and in different locations before, during, and after the field season. One thing that we've noticed, even in the course of this project, is that it seems to be a common thread of conversation within the terrestrial analogs community, and a common challenge, and that many people seem to be discussing how the PDS4 model is helpful, but not quite a fit for the way that data is generated in the field. When we look at our work currently, we're transferring our manually collected notes with our timestamps into spreadsheets and gathering them that way, and ultimately looking to correlate them to the data that's generated from our drill telemetry and also from our instruments. So our most recent intern from University of Puerto Rico, Javier Rodriguez, worked last semester to begin formatting a database and developing a schema that we could evaluate for linking our sample curation and our depth log to our drill telemetry. We're now in a phase where we're currently working to evaluate, one, how we want to visualize the spatial data component, as well as the time and other layers of sample analyses. Our ultimate conclusion has been that ArcGIS Online is probably the best option for us to go with for something that's a long-term location and a centralized location where our collaborators can access it easily. Currently, we're working on formatting and labeling conventions and the mundane details that allow us to link to that drill telemetry, and working also with the software itself that controls the drill to gather those reporting functions and merge that data in automatically. I believe I'm close to my time, so what I do want to say is that we're very eager to continue conversations and continue learning from our NASA and USGS colleagues. It's been very informative over recent weeks to see what other colleagues are doing, and we're looking forward to continuing that journey. Thank you.